Tonight's lesson is going to be 5-4, Triangle Midsegment Theorem. Our objectives: prove and use properties of a triangle midsegments. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Okay, so XY is an example of a midsegment because X is the midpoint of segment QP, Y is the midpoint of segment QR. Every triangle has three midsegments, 1, 2, 3, which form a midsegment triangle. So triangle XYZ is the midsegment triangle of the larger triangle PQR. Okay, the vertices of triangle XYZ are M and N are the midpoints of XZ and YZ. Show that MN is parallel to XY and MN equals half the distance of XY. Okay, so we've got our XY coordinates. We need to know what our MN coordinates are. What's telling you that M is the midpoint of XZ. So we need to find the midpoint of XZ. Okay, so midpoint of XZ. X is -1, 8. Z is 3, -4. So we've got 3 plus -1 over 2. And then we've got -4 plus 8 over 2. So we're going to get 2 over 2, which is 1, and we're going to get 4 over 2, which is 4. So there is your coordinates for M. And that is wrong, because 4 divided by 2 is 2. So let's back up here. -4 plus 8 is +4. +4 divided by 2 is 2. Okay, so let's find the midpoint of YZ, because that's going to give our coordinates for point N. Okay, so Y is 9, 2, Z is 3, -4. So we have 3 plus 9, and we have -4 plus 2. So we have 12 over 2, which is 6. We have a -2 over 2, which is a -1. So now we have our coordinates for N. All right, once you find your coordinates for N, let's look at what we're trying to prove right here. We're trying to prove that these segments are parallel. And in order to do that, we need to look at the slope. So let's look at slope of MN. Okay, and our coordinates were M is 1, 2, N is 6, -1. Okay, remember your slope is your vertical change over your horizontal change. So that's -3 over 5. Then we need to find the slope of XY, X coordinate, Y coordinate, vertical change over your horizontal change. So we have -6 over 10, which simplifies to divided by 2, so it's going to be a -3 over 5. So we can say that segment MN is parallel to segment XY because they have the same slope. All right, now we need to look at what we're trying to prove here. So we're going to have to think distance formula. Okay, so let's look at MN. Now remember, M is 1, 2. N is 6, negative 1. Okay? So we've got 6 minus 1 squared plus negative 1 minus 2 squared. 6 minus 1 is 5. 5 squared is 25. Negative 1 minus 2 is negative 3. Negative 3 squared is 9. So we get the square root of 34 for MN. Now we need to find the distance of XY. Okay? So 9 minus negative 1 squared plus 2 minus 8. 9 minus negative 1 is 10. 10 squared is 100. 2 minus 8 is 6. 6 squared is 36. So we have the square root of 136. However, we can simplify that radical because I know that 4 times 34 equals 136. So now we just proved that MN equals half of XY. Because MN is the square root of 34, and XY is double that. Okay, you've got another one just like that. Thought you might want to practice some of it on your own. If you need more practice, do this on your own, bring it to class, and I'll help you with it. But I'm going to move on. The relationship shown in example 1 and 2 is true for 3 midsegments of every triangle. So we have our triangle midsegment theorem. A midsegment of a triangle is parallel to a side of the triangle, and its length is half of the length of the side. So we just proved this, guys, that midsegment DE is parallel to AC. Also, midsegment DE is half the distance of segment AC. All right, so let's see if we can solve these. BD, that is the midsegment, and it's parallel to AE. Okay? So I can say BD equals half of AE because of your midsegment theorem. All right? So BD equals half of 17. Therefore, BD is 8.5. Now, we need to find measurement of angle CBD. CBD. That one right there. So we can say segment DF is parallel to segment AC because of your midsegment theorem. Guys, sorry about that noise. It is the vent probably getting ready to blow. So if these two are parallel, what do you notice about this angle and this angle? So we have angle CBD congruent to angle BDF because they are alternate interior angles. And then we can substitute in and say that this angle is equal to 26 degrees. Okay, I'm going to stop this and we're going to have a part 2. So I'll see you in just a minute.